All right, I'm here with 52 weeks of AWS. And last time I talked about the AWS security certification, and I got to module two. And I'm going to dive into in this episode securing access to cloud resources, which is module three from their official training material. Let's go ahead and get this cooking here. So, in a nutshell, with securing access to cloud resources, the idea here is to be able to understand how to authorize access to AWS web services by using AWS identity and access management. Also, learn how to differentiate between different types of security credentials in IAM, authorize access to AWS services by using identity based and resource based policies, and also identify other AWS services that provide authentication and access management services, and also centrally manage and enforce policies for multiple AWS accounts. All right, so to get into this, we're going to talk about IAM fundamentals, also authenticating with IAM, authorizing with IAM. Uh, Also, we'll talk about AWS organizations, which is a very interesting technology that many people don't use. And let's go ahead and get started here. So, to begin with, one of the things that is critical to be aware of is this concept of uh, you know knowing about different scenarios in terms of what it is that you're building, and in particular, a bank could be a good scenario here. And inside of a bank scenario, you'd want to know who's the customer and what part is AWS responsible for. These are typical things that you would figure out when you're building things. And if we dive into it a little bit further, the idea with a shared responsibility model is that the customer themselves is responsible for things like the customer data, the platform, application, identity, and access management. These are all things that are important to be aware of, and it's critical, in fact, to be aware of these things. And in terms of building out different parts of the platform, making sure that it's accessed from every location that you need access to. All of those things are really the shared responsibility, but AWS is going to handle the foundation services, the compute, the storage. Those are critical components of what happens when you're building alongside of AWS. So the shared responsibility is really the key for security with AWS. Now, in terms of the IAM fundamentals, let's talk about some of the things that happen here with IAM in particular. One of the things that's important to be aware of is that you're going through and is done there. Um, and one of the things that's important about this is that it's integrated into all of the services that you're using. Also, it's important to make sure that you're using IAM in a way that doesn't give too much access to other different resources, and that you're supporting more of like a granular permission level, and you're using things like multi-factor authentication. These are all critical components of dealing with the IAM system. In terms of what it does, it allows you to request access to the AWS account and the resources. You can also establish the identity of who's accessing the credentials. And in fact, inside of the AWS CloudTrail system, you can look at all the different requests that are being made as well. And then in terms of the authorization, this is when you would go through and look at, what's happening in terms of what's been allowed to do, different checks as well for policies. These are all done via the IAM, both authentication and authorization. So, in a nutshell, there are these four components here: the user component, which is a person or application that can authenticate with an AWS account, there's the group, which is a collection of IAM users who are granted identical authorization. So a good example would be you could have S3 read access. So that could be a group, or you could have a group called data scientists, and the data scientists can access certain resources like read write to S3, and maybe they can access AWS SageMaker. And then a role is something that is a temporary identity. So you can have a service make a request. A good example would be AWS Lambda. You tell Lambda that it can talk to SQS, which is the queuing service, and you can also talk to S3 to potentially write data to S3. Those would be things that the role would allow for that Lambda. And then a policy is the document that is going to define exactly what's inside of that that resource's ability to access things. So it's really like a statement that says what's going on with those resources. In terms of the terminology here, one of the things that is happening is that with IAM entity, this is used for authentication and roles. And in terms of resource, these are things that are, again, able to be edited inside the IAM system. And then a principal is a person or application that uses the root account, the IAM user, or the role to sign in and make requests. So it's really linked to a particular entity that's actually interacting with IAM. In terms of the requests, a request is made anytime a principal attempts to use the AWS console or the application programming interface, or the API, or the AWS command line interface, which is the AWS CLI. And then the request contains the following information: actions or operations, resources, principal, environmental data, resource data. All of these things are contained in the particular request. In terms of service endpoints, this would be something that allows you to connect to an AWS service, and you would use the URL of the entry point of that service. A good example of this could be something like the Elastic Compute Cloud, where it would have an endpoint that would be pointing to, let's say, US East, and then the AWS Software Development Kit, or SDKs, and AWS CLI use the default endpoint for each service, but you can specify alternate endpoints for an API request based on a configuration requirement. So some of the takeaways here is that IAM is a web service that lets you control access to AWS resources. So it's the place that you go to do this. This is the one place where this is controlled. And then authentication deals with the person that's requesting access, and authorization determines what they actually have access to. And then IAM would provide the users, the groups, the roles, and the policies to provide authentication and authorization for AWS services. So let's dive into authentication with IAM here next. Some of the things that are important to be aware of in terms of role characteristics is that it provides temporary security credentials. It also, a role is not uniquely associated with one person, and a person, application, or service can assume a role. And a role is often used to delegate access, and the AWS Security Token Service, or AWS STS, will issue temporary security credentials. So in this common use case here, you can see an application that runs on Amazon cloud, right, or EC2, the Amazon Elastic Compute Cloud, or across account access for an IAM user or a mobile application or AWS Lambda. So what happens is that you create some role, again, let's say read access to S3. The EC2 instance would then assume the role, and then there's a policy that's associated with that role. So let's say, again, that it has the ability to access S3, and then it can actually access the bucket. So it's actually a very secure way to handle servers accessing things, because the credentials are temporary and they're associated with essentially a compute node in this particular situation that's doing some kind of work. Now, in terms of the IAM credentials for authentication, when you interact with AWS by using the console or AWS CLI, you're going to have to provide the credentials. And what are the key things to be aware of is that you'll see this quite a bit with different services, is that you need to have, in general, the AWS Access Key ID. You need to have the AWS Secret Key. And typically, you'll also want to specify, if it's programmatic, what is the default region. So do you want to use US East or the Southeast? And then also, what is the format you want the request to come back as? For example, text or JSON. And in terms of the console, you would need to have the MFA, which is the multi-factor authentication, hooked in as well. Now, in terms of the multi-factor authentication, this is an extra layer that's on top of the username and password, and it could be either a hardware device or it could be a virtual device. And so you should it's recommended actually that you activate it for the console. You also could activate it though for AWS API users with temporary security credentials. Some examples would be security keys. So you could use something called YubiKey or Gemalto. Also, you could do applications like Google Authenticator or Authy, or actually just a physical hardware device that you could carry around with you. In terms of the authentication scenario here, the administrator would create a role that grants development account read-write access to the production bucket. This would be update app or production app. The user would request access to the role. There would also be the ability to return the role credentials, and then the user would update the bucket by using the role credentials. And then the admin would grant permissions to the members of the developer group to assume update app role. So that would be one potential authentication scenario. So in general, a good practice is to attach the IAM policies to the groups and then assign the users to these groups. So again, it would be very complex to manage individual permissions without groups. And a lot of times you'll have divisions in an organization that make a lot of sense. Again, data scientists, software engineers, QA testers, product management, and you could assign these policies to them. And then the IAM roles are temporary security. These are best practices for launching, let's say, EC2 instances that need to do something, or essentially compute is an easy way to point to roles, right? Because they need to do something and you give them these temporary security credentials versus putting hard-coded API keys onto the instances, which causes lots of problems. For example, if you needed to swap out the permissions, you would have to stop the instance and swap them out. It's just not a good practice versus the roles. And then AWS STS would provide the temporary credentials for a role. And then MFA would give you the extra layer of protection. So let's dive into authorizing with IAM next here. In terms of, this is a classic phrase here called the principle of least privilege. And the idea here is that you don't give people more permission than they need. You want to only grant them additional access when they need it. Because if you give them more permission than they need and there's a problem, then you're going to expose parts of your system that shouldn't be exposed. So that's really a best practice. And in terms of policies and permissions here, a few things to be aware of is that you can control the resources by using policies that both grant or deny as well. And then in terms of identity-based and resource-based policies, the identity-based would be, per user, for example, you could do read, write, list, and they could be, some granular level of permissions. And then in terms of resource-based, this would be, who has access to a particular resource, let's say a particular bucket. You could have read, write, list access as well. In terms of managed and inline policies, one of the big things here is that a managed policy is standalone, identity-based, and those can be attached to multiple users, groups, and roles. Some of the advantages of this is that it's reusable. There's central change management, versioning, rollback. The permission management can be delegated to others, and they provide the use of permission boundaries. And then there is also the inline, which allows you to have embedded into a principal user, like a user group or role. And you can also use the same policy for multiple entities that don't share the policy. And they're useful if you want to maintain a strict one-to-one relationship between a policy and the principal entity when it's applied. So, there's some use cases where both make sense. In terms of the logic for a policy, you can see here that the logic here is that by default, all requests are denied. An explicit allow overrides the default, but an explicit deny overrides any explicit allow. So some of the takeaways here is that permission to access AWS is from IAM policy docs, and the IAM policies uh, apply to users, groups, roles, and you should follow the principle of least privilege. And when you're using IAM to determine permissions, the explicit deny always has precedence. So some of the things that you really dive into here would be identity-based policy. You can see that these actions are allowed, and these you can also, like, for example, if I want to say a person can have a access key or public key, these actions are allowed. And you could also say the user could have access to particular resources, right? That would be identity-based policy. And then a cross-account resource-based policy would be that you can say account B, principal allowed by account A to make a request, and you could actually allow a particular account to do things as well with a cross-account resource policy. And you could also have an allow statement, and an allow statement in terms of an IAM policy would give, particular AWS S3 buckets, for example, or wildcards access, or access to a database. In terms of a deny, again, deny has precedence. You could specifically deny particular, databases, for example, like human resources databases. And the permission boundary here is that again, the deny has precedence. Okay, so in terms of identity federation, the idea here is that it's a way of having trust between two parties to authenticate users, and identity providers are responsible for the user authentication, and the service providers are responsible for resource. So two AWS resources that are available to do federation would be AWS SSO, and the other one is IAM. So in terms of the single sign-on or SSO, you could connect identities once and manage them across the AWS accounts, and you could have a unified administrative experience here, and you can configure access to replace different parts of the account management. And then there's also directory services for Microsoft Active Directory called AWS Managed Microsoft AD, and you could have directory type workloads as well, and you could extend maybe an existing Active Directory. A lot of large enterprises have Active Directory, so you could basically tie directly into that and extend it. There's also Amazon Cognito, which is something I've used before in production, and what's useful about it is that it integrates user sign up, sign in, access control for web and mobile. And it also is a secure identity store that can scale to millions of users with user pools. And it also has the ability to hook into social identity providers like Apple, Google, Facebook, and Amazon. And you can create unique identities for users and then federate them through Amazon Cognito identity pool. So basically, it's a glue for dealing with all of these different sign-in type profiles, and it makes it easy to integrate that into AWS. There's also AWS organizations, which are definitely an interesting technology that allows you to do a lot of neat things. So the idea here would be that with account management service, you can consolidate multiple AWS accounts and manage them centrally. This could be account creation and management. You could also have a hierarchical grouping of accounts. You could support policy controls. You could also integrate with IAM. So examples would be, you could prevent members from leaving your organization. Now let's talk a little bit here about some of the stuff we discussed. So we talked about AWS services, uh, IAM users, groups, and roles. The key takeaway here is that you should use groups to manage users, roles for services. And then we also talked about the different kinds of security credentials in IAM. We also talked about authorization based on identity or resource. So identity again would be, a person can access particular things, and a resource is the resource can be accessed by these people. And then we also talked about identity and other AWS services for authentication and access management, and then talked about the central management things like, for example, organizational units. So that's it. That's a pretty beefy bit of information. Next time in a couple weeks, what I'll cover is I'm going to cover securing your infrastructure, and this will cover getting into a little bit more of the weeds on security. So again, the idea here with this particular next several weeks would be going through the AWS security specialization. All right, thanks for everybody that stayed tuned.